Mind your decisions, I'm Presh Talwalkar. I'm thinking of two regular polygons. One polygon has m sides and dm diagonals, and the other has n sides and dn diagonals. If dm plus dn is equal to 125, solve for the value of m plus n. A version of this problem was asked in the 2018 Math Counts National Competition. Students had less than 1 minute to solve this problem without the use of a calculator. I admit it took me about 5 minutes to solve, so I think it's okay if you take longer to solve this problem. I thank Patrick from Germany for the suggestion. Pause if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. I'm first going to present two formulas for the number of diagonals in a polygon with k sides where k is greater than or equal to 3. I'll then illustrate how to solve the problem quickly. One formula is an explicit formula. dk is equal to k multiplied by k minus 3 all over 2. This is useful if you want to evaluate a particular value like k is equal to 100. Another formula is known as the recursive formula. This is dk is equal to dk minus 1 plus k minus 2. This is useful for computing the next value if you know the previous value. This is useful if you want to create a table, which is what we need to do in this problem. Before I get to that, let me prove both of these formulas. I'll first prove the explicit formula by direct counting. In a polygon with k sides, we have k vertices. How many diagonals can we draw from a particular vertex? Well, notice that the adjacent vertices will form sides with this vertex. So these two sides will not be diagonals of this polygon. We also cannot draw a diagonal between the vertex and itself. So these three vertices will be excluded in the count of drawing diagonals from this vertex. But every other vertex will form a diagonal with this vertex. Therefore, we have k minus 3 diagonals that we can draw from this vertex. If we do this for all k vertices, we have k multiplied by k minus 3. Now we have to make one more adjustment. Every single diagonal involves two different vertices. To avoid double counting, we therefore have to divide this by 2. And thus we have k multiplied by k minus 3 all over 2, and that's one way to prove the explicit formula. Another way to prove it is by considering the complete graph. Consider k vertices as before. Now, let's connect every pair of vertices with an edge. In total, we will have k choose 2 edges because every pair of vertices will make an edge. Now, every edge is either a side or a diagonal of this polygon. But remember, there are k sides to this polygon. If we subtract the second equation from the first, we get a count of the number of diagonals. K choose 2 is equal to k multiplied by k minus 1 over 2, and when we subtract k, we get k multiplied by k minus 3 all over 2, and thus we've proven the formula in another way. So now, let me prove the recursive formula. Suppose we have k minus 1 vertices, and we have a formula that counts the number of diagonals. How many more diagonals will we have if we add one more vertex? That is, if we have a k-sided polygon with k vertices. Well, as before, these three cases will not be diagonals of this new polygon. But every other connection will be a diagonal of the polygon. So we need to add on k minus 3 more diagonals. Now, if we connect the adjacent vertices to make sides of this polygon, let's examine what happens to this previous side of the previous polygon with k minus 1 vertices. Well, notice that this will actually be a diagonal of the new polygon. So we need to add one more to this formula. The result is that dk is equal to dk minus 1 plus k minus 3 plus 1. And that simplifies to be dk minus 1 plus k minus 2. And that's the recursive formula we'll need to solve this problem quickly. So now let's solve the problem quickly. For fun, let's see how long it takes. We'll first create a table for the number of diagonals. A triangle with 3 sides has 0 diagonals, a quadrilateral has 2 diagonals. To get d5, we take d4 plus 3. This will be equal to 5. Then d6 is equal to d5 plus 4, so we get 9. To get 7, we add 5. To get 8, we add 6, and we quickly compute all of the values in this table. We want to exceed 125 diagonals. Then we look for a pair that has a sum of 125. This will be 35 plus 90, corresponding to d10 plus d15. Therefore, m plus n is equal to 10 plus 15, which is equal to 25. And that's our answer. And we solved it in just under 40 seconds. I think this is a really fun problem. Thanks for making Mind Your Decisions one of the best channels on YouTube. As always, thanks for watching and thanks for your support.